Hey folks, how's it going? This is Mr. Murray coming to you with a little video summing up the circle angle relationships that we have been talking about today. This content comes from the Integrated Math 2 text, section 19.5, and in this section we look at a number of different relationships with angles. We've talked about some, such as the fact that inscribed angles are half the measurement of the corresponding central angle. We talked about how a circumscribed angle's measurement is supplementary with the corresponding central angle. We talked about stuff like that. Now, in this section, we look at other relationships. Some include when you have the intersection of two chords, when you have a tangent, an angle formed by a tangent and a secant, and when you have an angle formed by either two tangents, two secants, or a secant and a tangent, and they intersect outside of the circle. Okay, so in today's lesson, what you did is you looked at 3 different GeoGebra sketches. These were included in the lesson notes. So you want to look at the 5/7/2020 lesson notes. And in those notes, you're going to see sketches for each of these. What you want to have done by the time you're viewing this video is gone to each sketch and read the directions on the sketch. In the sketch, it explains to you which points or things or whatever it wants you to manipulate. Do that and then look at the values that I've put in there and with the text, and look at how those values are changing and how they compare to one another as you move certain things around. Okay? I thought that maybe we would have an opportunity to discover some things and play around with some things and have it be a little bit more interactive rather than just saying, here's the way it is. Okay, so hopefully this video will confirm what you were able to find by exploring those. So the first one is with intersecting chords. And what we know is that if two secants are chords, so they could even be secants, they don't have to stop at the points, they could go on forever because we're just focused on what's happening inside the circle. If they intersect here in the interior, such as at point E, then the measure of each angle formed is half of the sum of the measures of the intercepted arcs. Okay, so essentially what that means, if you look at that, is that this is essentially half of the sum of AB plus CD. So what you should have noticed is, first of all, these are congruent because they're vertical angles. And then the second thing you should have noticed was that they were equal to half of AB plus CD. So for example, if AB was like, I don't know, 100 degrees and CD was like 40 degrees, right? Then if you add them up, you get 140. So 1 would be 70 degrees because it would have to be half of that. You could also view this as the average of the arcs because when you add up two numbers and divide by 2, that's the mean and also technically the median. But that's the relationship we have there. Okay, so let's take a look at a couple problems here. So here I give you a circle and I give you the intersection of a diameter, which is technically considered a chord, and a secant, a line that goes on forever and touches the circle there at those 2 points. All right, and I want to find the measurement of MPK. Okay, over here, I need to find the measurement of PR when I know this. So what I want you to do, take a moment, pause the video, try to find these 2 unknown measures, and then when you're ready, unpause, and you can see what I got. Okay, great. So what we know is that MPK is half of the sum of these 2. So I take 111, I add 61, I get 172. I do half of that. And I get 86 degrees. Okay? And that's what you get. So because this theorem says, and if you look at, I would say go back to the GeoGebra sketch. See if you can't actually set this up on the GeoGebra sketch to confirm it. Okay, here I know that 58 equals 1/2 182 plus, let's say we call this x. Okay, so we could multiply, we could distribute. How about we distribute? So we get 58 equals 91 plus 1/2 x. Wait, not 182. Whoa, what's going on? Sorry about that, folks. Positive 82. So 41. That'll make sense. So 58 minus 41. And then you multiply by 2. You get 34 degrees. And that is the measurement of PR. So you know that this intersected angle at this chord will always be the average of these two measurements. Okay, you can also use the fact that these add up to 180, right? You could do other cool things. Like you can say, oh, this is 58. So here would have to be 122. These would then add up to 180. Okay, and then you could use that, right, if you were able to know one of these measurements, right, like especially if this is one of these was like a diameter, you could figure out a lot of stuff just by using this principle here. Okay. Relationship number 2. The tangent secant interior, so there's an interior and an exterior. This is an interior angle because this angle, right, this vertex, notice how it's on the circumference of the circle, versus if the vertex was outside the circle, exterior, right? So if a tangent and secant, or a tangent and a chord, right, this could have also just been a chord and stopped there, intersect on a circle at a point of tangency, so it has to specifically be the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. In other words, this measurement should be half of the arc, and that's what you should have seen if you did the GeoGebra sketch. Then it was very difficult in GeoGebra to get the tangency perfect, and that's what threw it off from being completely half sometimes, but almost all the time this angle should have been half the curve. Okay, so let's see if we can use this now. So here's an example of how this works. So if I want to find measurement of BCD, okay, what I know is that if this is 142, if this arc is 142, this piece has to be half the arc. So it has to be 71. What if I want to find ABC? Well, ABC, what would that be? So let's look at ACD. Measurement of ACD is equal to half of this measurement, right? And the measurement of ACD, as you can see in the picture, is 90 degrees. So you can actually see, and this proves that ABC is actually a diameter. And you know that because this is a 180 degree angle. The arc, that is. Because this is 90. Okay? Alright, folks, so here we go. We've got this problem right here. So you can see we've got a bunch of similar problems. What I want you to do, take a moment, pause the video, solve these, and then when you're ready, unpause and you can see what I got. Okay, so we need to find the measurement of Pn and the measurement of MNP. Now, the measurement of MNP, well, this has got to be half the measurement of the corresponding arc. So we got to find a couple of things going on. And then I noticed this is a 61. I'm assuming that this is a 61. So I think that would make Pn 122 because it has to be 61 times 2. Now, I noticed that 238 plus 122 is 360, so that is a good sign. And then MNP needs to be half of this arc right here. So if that's 238, this needs to be 119 degrees. So here, although they were numerically sequential, that is, one came before the other, it doesn't seem like one actually relied on the other. Okay, last concept here, tangent secant exterior angle measure theorem. So here you have this. Now notice the word exterior, and that's because you have things meeting on the outside of the circle. So if a tangent and a secant, two tangents or two secants intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. That is, you take these, you take the difference, and notice how it's going to be the bigger minus the smaller. Notice how it says EHG. That tends to be what you have when you get like what's called like a major arc. And the EHG is giving you the sign, oh, I want you to actually go this way, right? EG versus if I give you these two, the H is giving you a sense of, so you know which one is which. Otherwise, if I did EG and EG, you wouldn't really be able to know which one I was talking about. Or you might say 0, understandably, okay? And then over here, right? So again, we have a secant and a tangent, two tangents, two secants, but it's always the difference of the bigger minus the smaller times a half. All right. So let's just briefly take a look at some of these in terms of how we find these. So here's an example done out. So let's say I want to find x. Well, I know that 25 is going to be the difference of 83 and whatever this is, half of that rather, right? So I take this, I subtract x, I got to divide that, right, by 2, and that gives me 25. So if a number divided by 2 was 25, well, what I want to get to is 50, right? I want to get this to be 50 so that when I have it, I get 25. And then from there, we can solve it out. In this case, they subtract 83, and they just flip the signs, right? Multiply by -1, divide by -1, either way. Here, I want to figure out x. So I know x is a half of the difference between this and this. Now, why do they do 360? Well, because these are tangents, what we know is that these are the only two pieces of the circle. And since the circle's angles must always add up to 360, right? This always adds up to 360. If I know one piece and I want to find the other, I just take everything and I subtract that one piece, and what remains is the other piece. Okay? So then I do 360 minus 238. Unfortunately, I don't have my simulator. I've got to use it on my calculator. And I get 122. So now I've got to take the difference, 238 minus 122. And I get 116. And I take half of that. and I get 58. So that is my measurement. And that's just the idea. You're just taking this rule here and you're applying it. Okay, so lastly, I just got this last example. What I want you to do, take a moment, pause the video, try to solve this one, and then when you're ready, unpause, and you can see what I got. Wow, okay. So here again, we know that x is equal to 1/2 the difference of the bigger minus the smaller. Now remember, a measurement, it's an angle. It's got to be positive, right? You can't say there's negative space between these lines. Now, there are such things as negative angle measurements in theory. We have talked about that in a subsequent chapter. But for all intents and purposes, you can assume that the measurement's going to be positive. So one way you're going to know you did something a little bit wrong is if you flip the 161 and the 67 around, you're going to get a negative number, and then x is going to be negative. And that's going to tell you, wait a minute, I need to look at the order of things. Okay, so I'm going to do 161 minus 67, and that is 94. And half of 94 is 47. So x is 47 degrees. All right. So, all right, folks. So this is going to actually take us to the end of this unit. Okay, so in this unit, we talked about so much stuff. We talked about arc lengths. We talked about sector areas. We talked about degrees and radians. We talked about all different kinds of things with circles, inscribed angles, central angles, tangents, secants, all kinds of stuff. But what I'm going to ask you to do for today is 1, make sure you've done the explorations. 2, thank you for watching this video. And now I'm going to offer you a 5-question just sum up to make sure you absolutely understand these ideas. And then what we're going to be doing with this unit is we're going to be winding down with it, doing a little bit of review, and hopefully doing a little bit of an assessment next week. Please remember I'm available every Tuesday morning at 10 a.m. And don't forget our Hangouts Wednesdays usually at 3. Otherwise, I'll let you know. But please, please, please make the most of this final part of the year. Thanks for watching. Have a great day, and I'll see you next time.